In this tutorial we are looking at Pythagoras. Now Pythagoras theorem only applies to right angle triangles where we call A and B are two sides of our triangle that is not the hypotenuse. It's always important that C is labelled as the hypotenuse, which is the side opposite your 90-degree angle. Now Pythagoras' theorem is a squared plus b squared is equal to c squared. Let's do an example of a right angle triangle with base length 4, height 3, and we are trying to work out the length of the hypotenuse. Step 1, we label our triangle A, B and C. It doesn't matter which way round you label A and B, as long as C is always the hypotenuse. So let's substitute in 4 squared plus 3 squared equals c squared. 16 plus 9 equals c squared. 25 equals c squared. We just want to find c, so we need to square root to get a value of our c to be 5. Let's look at another. Step 1, we label A, B and C. Identify your hypotenuse. Next we substitute in A squared plus B squared. This time it's the B squared we don't know. So 8 squared is 64 plus B squared, which we don't know, equals 10 squared, which is 100. So we're going to do 100 minus 64, which is 36. So b squared is equal to 36. Now we need to square root to find b, and b is 6. Now Pythagoras can also come up if we are looking at rectangles or squares and we want to find the length of the diagonal. We can use Pythagoras here. Perhaps we could also use Pythagoras in volume questions if we're trying to find the volume of a triangular prism, and perhaps we know that this is 10 and this is 8 and this is 12. Now what we want to do is to find the area of our two-dimensional cross-section, so we would need to do the base times the height. So we would need to find the height using Pythagoras, which is the same triangle as we've done here. And then we find the area of our 2D triangle, our cross section, and then we multiply it by the depth to find the volume.